Have you ever wondered why two people can walk into a casino or try the exact same substance and walk away with completely different lives? One might enjoy themselves and never think about it again, while the other becomes trapped in a cycle they cannot escape. For decades, society viewed addiction as a moral failing or a simple lack of willpower. But modern science has revealed a far more complex and fascinating truth. Addiction is not a choice. It is a profound neurological puzzle. Today we are going to dive deep into the human brain, genetics, and environment to answer the ultimate question: why do some people get addicted while others don't? Let's unlock the science of vulnerability. To understand addiction, we first have to understand how our brains are wired to keep us alive. Every time we eat a delicious meal, hang out with friends, or achieve a goal, our brain releases a chemical messenger called dopamine. Dopamine is often called the pleasure chemical, but it is actually the molecule of anticipation and motivation. It tells your brain, "This is good for survival, remember how we got this and do it again." This is our natural reward pathway, centered in a deep brain region called the nucleus accumbens. It is an ancient survival mechanism designed to make us repeat life-sustaining behaviors. But addictive substances and behaviors hijack this very system. Whether it is nicotine, alcohol, gambling, or social media, they flood the brain with dopamine at levels far beyond anything nature can produce. A delicious meal might cause a moderate bump in dopamine, but certain drugs can spike it by up to 10 times that amount. This massive surge creates an intense artificial high. The brain, which loves balance, quickly realizes it is being overwhelmed. To protect itself, it begins to adapt. It starts pruning away dopamine receptors and producing less of the chemical naturally. This is the beginning of tolerance. The genetic blueprint. Now, if everyone's brain reacts to dopamine, why doesn't everyone get addicted? The first major piece of the puzzle lies in our DNA. Scientific studies, particularly those involving identical twins raised apart, estimate that genetics account for roughly 40 to 60% of a person's vulnerability to addiction. There is no single addiction gene that dooms someone from birth. Instead, it is a complex combination of hundreds of tiny genetic variations that influence how our brains process rewards, handle stress, and control impulses. Some people are simply born with a brain chemistry that is more susceptible to being hijacked. For instance, some individuals naturally have fewer dopamine D2 receptors in their brains from birth. For these people, everyday life might feel slightly less vibrant or rewarding. When they encounter a substance or behavior that floods their system with dopamine, it can feel like a light switch has been flipped on for the very first time. They experience a profound sense of feeling normal or complete satisfaction that others who have a normal baseline of dopamine receptors simply do not experience. For them, the memory of that first high is incredibly powerful and hard to forget. Conversely, some people have genetic variations that make the experience of certain substances highly unpleasant. Take alcohol, for example. When we drink, our body breaks down alcohol into a toxic byproduct called acetaldehyde, which is then quickly cleared by an enzyme. Many people of East Asian descent carry a gene variant that slows down this clearance, causing acetaldehyde to build up rapidly. This leads to facial flushing, nausea, and a rapid heart rate. Because the physical reaction is so uncomfortable, individuals with this genetic variant are statistically far less likely to develop alcohol addiction. The power of environment, but genetics are only half the story. As the famous saying in science goes, genetics loads the gun, but the environment pulls the trigger. Our surroundings, especially during our formative years, play a massive role in shaping our brain's vulnerability. One of the most significant environmental predictors of addiction is childhood trauma. This includes physical, emotional, or sexual abuse, neglect, or growing up in a household with domestic violence or substance abuse. These experiences are collectively known as adverse childhood experiences, or ACEs. When a child grows up in a constant state of fear or instability, their brain is bathed in stress hormones like cortisol. This chronic stress alters the development of the prefrontal cortex, the area responsible for decision-making, impulse control, and emotional regulation. It also desensitizes the reward system. As a result, individuals who have experienced high levels of childhood trauma often enter adulthood with a highly sensitive stress response system and a compromised ability to naturally experience joy. For them, Addictive behaviors can become a form of self-medication to soothe pain. Beyond trauma, immediate social environments hold immense sway. Peer pressure, cultural attitudes towards substance use, and the sheer availability of addictive outlets shape our choices. If a teenager grows up in a neighborhood where drug use is highly visible, or in a family culture where heavy drinking is normalized, the barrier to entry is incredibly low. Early exposure is critical because the adolescent brain is still undergoing massive rewiring. Introducing highly stimulating substances during this critical window can permanently alter the brain's developmental trajectory, cementing pathways of addiction. The brain's control center. To truly understand why some can stop and others cannot, we must look at the battle taking place inside the brain. This battle is fought between two main regions: the amygdala, which drives our emotions and desires, and the prefrontal cortex, which acts as the logical brakes of the brain. In a healthy brain, the prefrontal cortex easily overrides impulsive urges. It says, "Yes, that looks fun, but we have work tomorrow, so we should stop." It weighs long-term consequences against short-term rewards and keeps our behavior aligned with our goals. In a brain vulnerable to addiction, however, this communication system is severely compromised. Chronic exposure to addictive substances weakens the connections between the prefrontal cortex and the reward center. It is like driving a car with incredibly weak brakes. The urge to consume or engage in the behavior, driven by a hyperactive amygdala, becomes an overwhelming roar, while the logical voice of the prefrontal cortex is reduced to a whisper. The individual is no longer choosing to engage in the behavior. Their brain is operating in a state of perceived survival. This is why shaming someone with an addiction is not only cruel, but scientifically illiterate. You cannot simply willpower your way out of a condition where the brain's willpower engine has been physically damaged. When an addicted person encounters a trigger, like a specific street corner, a certain friend, or even a stressful day, their brain experiences a massive drop in dopamine, creating an intense, agonizing craving. The brain genuinely believes that obtaining the substance is a matter of life or death, overriding logic, love, and self-preservation. The famous rat park experiment. To see the power of environment and connection in action, we have to look at one of the most famous psychological studies of the 20th century, rat park. In earlier addiction experiments, rats were placed in small empty cages with two water bottles, one filled with pure water, and the other laced with heroin or cocaine. In these isolated conditions, the rats would almost always become obsessed with the drugged water, drinking it until they overdosed and died. For a long time, researchers pointed to this as proof that drugs were inherently so addictive that no one could resist them. But in the late 1970s, a psychologist named Bruce Alexander noticed a flaw in these studies. The rats were isolated, lonely, and had nothing to do. So he built Rat Park. This was a spacious, beautiful enclosure filled with toys, tunnels, delicious food, and most importantly, plenty of other rats to play and mate with. They had access to the same two bottles, plain water and drugged water. The results were astounding. The rats in Rat Park, living happy, connected lives, almost entirely ignored the drugged water. Even those who had been forced to consume drugs beforehand chose to stop. This groundbreaking study proved that addiction is not just about the chemical hooks of a substance. It is heavily about our cage. When we are isolated, stressed, and disconnected from meaningful relationships or purposes, we are far more likely to turn to artificial sources of comfort. But when we feel safe, valued, and connected to a community, our natural reward systems are satisfied, and our vulnerability to addiction drops dramatically. Connection, purpose, and a supportive environment are some of the most powerful shields we have against addiction. So, why do some people get addicted while others don't? There is no single answer. It is a deeply personal intersection of our genetic blueprint, our childhood experiences, our brain structure, and the social cages we find ourselves in. Understanding this science changes everything. It shifts our perspective from what is wrong with you to what happened to you. It shows us that recovery is not about punishment, but about healing the brain, rebuilding connections, and changing environments. If we want to solve addiction, we must build a world with more support and fewer empty cages. Thank you for watching. If you found this video insightful, please hit the like button Share it with someone who might need to hear this,